We have three special limits that we're going to discuss, and here they are. The first one, the limit is x approaches 0 of sine x over x. Well, I wonder what that could be. So here's what I've done, actually. I have typed them in to my calculator, all three of them, and we're going to graph them one at a time. I've adjusted my window accordingly. So we're going to find out what these limits are just looking at the graph. So here's the graph of the first one. I want to see what happens as we approach an x value of 0. It just happened while I was talking. It happened right there, and the y value is 1. It's not a proof by any means, but I'm just using this to demonstrate that this is equal to, well, 1. You need to memorize that. You need to know that. That's why it's in a little box. Okay, the limit is x approaches 0 of 1 minus cosine x over x. Well, let's turn that one off and turn that one on. You can, by the way, you can go to the equal signs and you can turn them on or off. So here is the second one in red. Oh my goodness, it looks like it, I almost said it touched at 0. It can't exist at 0, but the limit is 0. So this one is equal to 0. And the third one is not going to be as obvious, and we're not going to use it as much, but it's good to know. The limit as x approaches 0 of 1 plus x to the 1 over x. We'll turn that on and we'll graph it. See a few random dots, and then, oh, there it goes. Something up here. I wonder what that is. And knowing the answer, I'm going to go ahead and show you what it is. If I graphed the number, I'm about to give it away, e, then you would see that this graph crosses. I say that loosely because they don't actually touch at that point because x doesn't equal 0 for this function. But they cross at e. They don't technically cross, but you know what I mean. I hope you know what I mean. What I'm trying to say is this limit is equal to e. So we're going to use these three things, specifically these two, for these, because these involve trigonometry. And things are going to get a little bit tricky as we kind of pick this apart. And we're going to use the properties of limits for this. So here we go. Let's switch colors. What color shall I use? Green. Green's always a good one. And you're like, no, I don't like green, so you just turn the video off. Man, green was stupid. I think we should break this up into two separate pieces. And why? Because I know these three things. Well, I'm focusing on these two. Because I know these two things, I am going to aim to turn these individual things into these things as much as I can. It's just a good strategy to use. So I see sine x over x squared. Well, let's just say that it was sine x over x, okay? If we had sine x over x, that'd be the first part. And the second part is 1 minus cosine x over x. Again, basically, I'm breaking this up. I'm factoring it into two separate pieces. And we have the limit as x approaches 0 for this entire thing. Let's put the whole thing in parentheses. So we have these two fractions that, if multiplied together, in the denominator would give me x squared. Check. And in the numerator would give me sine x times 1 minus cosine x. Check. So what I really have is way too much writing. Don't feel like you have to write all this, but I have the limit as x approaches 0 of sine x over x times the limit as x approaches 0. I had a hard time dotting my I there, didn't I? 1 minus cosine x over x, which means this one is equal to 1. This one is equal to 0, and I multiply 1 by 0, and I get 0. All that just to get a 0. Man. Wasn't that great? Okay, the next one is a little bit trickier. They're going to get progressively trickier as we go. Tangent x over x. Well, I don't see a tangent here. Well, I don't either. But something that I know and you know is that tangent is sine over cosine, right? Right? Right. Okay. Now, eventually, I'm going to aim to get one of these. I'm going to go ahead and tell you we're not going to get this one. This one has two terms in the numerator. That's one term. There's some funky ways where we could maybe make that work in other contexts. Not today, not on this problem. So we really have the limit as x approaches 0 of, well, tangent is sine x over cosine x, and all that is divided by x. So I'm going to take a couple steps and explain some things in terms of rational function and that sort of thing, just to kind of rational expressions and simplifying, just to kind of break this down to where at least one factor of it looks like that. Exactly one factor of it looks like that. So we have the limit as x approaches 0 of sine x. Best way to go about this. Let's just jump straight into it. We'll call it over I'm thinking of all the multiple ways I could do it. We'll do that. Do you have to think like that? No. Is this the only way to do it? No. Is this the best way to explain it? In my head right now, it is. Yes. So I have sine x times 1 over cosine x, and that would give me sine over cosine, which is tangent. And I hope you notice that this is that thing that we just learned, which means we have the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of 1 over cosine x. Okay, so we have these two things. We're multiplying them together. I didn't put parentheses on these. Not that I have to, but for some reason in this context, they just looked cleaner. I don't know why. Okay, this is 1. And you might say, well, I can't plug a 0 in here. I'm plugging a 0 into the denominator. Yeah, you're plugging a 0 into the denominator. Cosine of 0 is what? 1. I have 1 over 1, which is 1. Final answer is 1. Man, that was fun. Okay, in this one, we are going to unadd fractions. Don't you mean subtract? Well, no, I'm going to break apart two fractions that are added together. For example, random piece of scrap paper. If I wanted to add 5 over 7 and 1 over 7, I would have 6 over 7, right? Oops. There, we'll write it correctly this time. But if the problem started like this, if I started with the problem that said that, you could say, well, that's just really 5 over 7 plus 1 over 7. Okay? That's what I'm going to do. Common denominator is already staring us in the face, and that common denominator is x. So I really have, we'll call it x over x, oops, x over x, and we have sine x over x, and we have limits going on here. Well, I really spread that out, didn't I? This is the limit as x approaches 0 of x over x plus sine x over x. And I'm going to write the extra little step in the middle. It's for fun. Limit as x approaches 0 of x over x plus the limit as x approaches 0 of sine x over x. And we're at this point, hopefully, looking at that saying, well, I know that one. That one's obvious. We figured it out a minute ago. It's great. But what I don't know is what this one is. I'm going to use a little bit of very obvious algebraic manipulation. X divides into itself one time. I have the limit as x approaches 0 of 1 plus this little guy, which is 1. And if I am approaching 0 for every x, but I have no x's, then I don't really have a limit that I'm truly dealing with here. I have 1 plus 1. I don't know why I put double equal marks. Apparently I'm super excited about this. It equals 1 plus 1, which of course is 2. If you don't know 1 plus 1 is 2, then we have some serious issues in this class. But it is a matter of getting to this 1 and this 1 that were the tricky parts. I like how that whiteout just blends right in. You'd have no idea it was there. And that I just made another smudge here. Let's put some more whiteout. You'll never know it. All right. That's bothering some of y'all, isn't it? The next one, I'm going to aim for basically one of these, if I can. Again, not this one. This has trig in it. That doesn't. So probably not something we should aim for. Not in this context. So I'm aiming for sine x over x, and I believe I can. So let me show you a little bit here of where this is going. Limit as x approaches 0. I hope you notice that there's a greatest common factor down there, and it is x. So we factor that out. Okay, there it is. And I also hope you notice that we are basically multiplying a couple things together, and if you don't see it yet, you will in a second. So we have the limit as x approaches 0 of sine x over x times 1 over 2x minus 1. And so we have all that. And that leads me to the next step. It's another property where I am multiplying the limit of this one times the limit of that one. And I'm going to write the step, but if you don't write it every time, that's totally okay. Running out of space over here, it's going to look like it runs into the next problem, so I'll bring it down. This is the limit as x approaches 0 of sine x over x plus the limit as x approaches 0 of 1 over 2x minus 1. And this little guy right here, we know it, it's 1. We figured it out hours ago. And this one, we can plug a 0 in, and we do. We plug a 0 in, we have 2 times 0, okay, great, minus 1 is negative 1. So we really have 1 over negative 1. Final answer is 0. Okay. Here we go. The very last one. I hope you see what's about to happen on this one. We basically have the same thing in the numerator and denominator, and having that same thing in the numerator and denominator is going to give me, I'm just going to jump straight to the final answer. It's going to give me a 1. Okay, same thing in the numerator and denominator. Let me try this again. Sine x over x, it was just 1. Okay? The limit as x approaches 0 of sine 2x over 2x. It's just 1 because that's 2x and that's 2x. And we're going to encounter some exceptions to that. Let me demonstrate this one to you. I'm going to clear out this one and clear out this one and clear out the e as well. And I'm going to put a 2x right here, and I'm going to put a 2x right here. Oops. And the answer is still 1. Okay? The answer is still 1. And if you're confused about why, I just want to demonstrate one more time and try to explain it with a purple pen. That in this case, we're approaching 0 for x. Well, this is x and this is x. Well, in this case, they are the same. 2x and 2x. They are the same thing. If this was a 2x and a 3x, we'd have some issues, and we wouldn't quite be approaching the same thing for the numerator and denominator, where one of them is the sign of that thing and the other one is that thing. These need to be the same in order for this to be a 1. Okay? Later in other lessons, they will not be the same. But for now, they are the same, and that equals 1.